Good morning to all the students. Welcome to physics class. My name is Virender and I will teach you physics subject. You have already done your half of the TET chapter, that is current electricity, and now we will start with the Wheatstone bridge. Uh, Before starting this, you should also aware of Kirchhoff's law, that is first law and second law, because Wheatstone bridge is basically the depends upon the Kirchhoff's second law, that is the loop law. Now the Wheatstone bridge mainly consists of four resistances. One is P, Q, R, S. Four resistances. You can easily see in the diagram there are four resistances P, Q, R, S, and a battery E is the symbol for the battery. This battery is attached at terminal A and terminal C. Now if we see the current in the circuit, then here I current is flowing in this circuit. Now at point A there are two paths for the current, so current will be divided. Some of the current will flow in the resistance P and some of the current will flow in the resistance R. So we suppose that I1 current is flowing through P and I2 current I minus I1 current is flowing through the R. Now we can see easily there is a galvanometer attached between ends B and D. Now we know very well the galvanometer. What is galvanometer? It is basically a device which detects current in the circuit. So it detects whether the current is flowing in the circuit or not. So here galvanometer is attached. Now if it deflects, then it means there is some current, that is Ig, is flowing from B to D, and if it is showing zero current, that is no deflection, it is showing, then it means that Ig is 0 and there is no current flowing from B to D. In this condition, when Ig is 0, the Wheatstone bridge is said to be in balanced condition. What does it mean? It means that the potential difference across B and potential difference across D will be equal. Hence, no current can flow through the BD branch, BD circuit of the circuit of the Wheatstone bridge. So, because potential here also suppose at B potential is 20, at D potential is 20. So the potential difference, there will be no potential difference between B and D because there is equal potential. So due to no potential difference, we know that for flow of current we need potential difference. If there is no potential difference, then current cannot flow. So if the B and D both are at same potential, then there is no potential difference. So there will be no Ig current and no current flowing through the galvanometer. Now suppose this Wheatstone bridge is not balanced, means there is some current, Ig current is flowing through the galvanometer. Then here we can easily see I1 is flowing up to B, but after at point B there will be two paths for the current. One is this path and second is this path. So some of the current would like to flow through this path and some of the current would like to flow through this path. So here if we see uh, the current flowing through this path, we have already named it and it is Ig. So after point B, the current flowing through resistance Q will be I1, because this was I1, and Ig as divided in this circuit, in this branch. So what is left here? Here left is I1 minus Ig. So current flowing through resistance Q will be I1 minus Ig here. Now similarly, the current flowing through R, we have already discussed that it is I minus I1. Now up to point D, it will be I minus I1, but at point D there are two currents are meeting at point D, which are Ig and second is I minus I1. Now here first law of Kirchhoff's apply, that is here the current flowing through the resistance S will be the sum of current Ig and I1. So the sum will be I minus I1 plus Ig. So this is the current flowing through resistance S. Now after point C, both currents meet at point C, so there will be some algebraic sum of these two currents, and the sum will be here it is I minus I1 plus Ig, and here it is I1 minus Ig. So sum will be simply I. So current flowing through this path will be I. Now here I current is flowing from C point and flowing up to point A. Now here we will apply Kirchhoff's loop rule. Now we have considered first loop ABDA, which is that here A, B, D, A. This is the loop 1, or we can say we will apply the Kirchhoff's second law on this loop. Now here if we see, we know very well about the loop law. Here if we apply the loop law, then the first here the potential difference here it will be I1 into resistance P, because we know that potential difference is equal to product of current and resistance. So here the current is I1 and the resistance is P. So the potential difference here will be I1 into P. So I have written here I1 dot P. So minus is also here, but it is somewhere at the bottom. So please remember it is I1 negative I1 dot P. Similarly here if we go like this, calculating like this, then next path will be A to B, B to D, D to A. Okay, now we have calculated up to A to B. Now B to D there will be potential difference will be current into resistance. So current is Ig and resistance is G. G, that is galvanometer resistance. Now it will also be negative. How we can determine that the sign will be a sign convention? How we can determine the sign convention that the potential difference is negative or positive? So the rule for this, we can assume that if the our calculation direction and the direction of flow of current are same, then we will take negative direction, negative potential difference. Here we are calculating in clockwise direction, so the direction of the current is also a to b, and calculation the direction of calculation is also a to b, so both are in same direction, so we will take the potential difference negative. Now here also, if we see, the our calculation direction is a to b, b to d. Now here our calculation direction is b to d and current direction is also b to d, because Ig is flowing b to d, so both are in same direction, so we will take potential difference negative. So here also potential difference is product of current and resistance, so potential difference will be Ig dot G, so it will be negative. Now if we want to calculate the potential difference, because of we are calculating potential difference in this loop, as we have studied that the second law of Kirchhoff, because we have studied the second law of Kirchhoff. So in Kirchhoff's law, the potential difference, if we calculate the potential difference in a loop, closed loop, this is a closed loop which is A to B, B to C, C to A, है ना? So if we calculate potential difference across this loop and we add the potential difference, the sum of potential difference in a closed loop will be equal to 0. And we have studied how to calculate the potential difference in closed loop. We have studied this in second law of Kirchhoff. Now here we have calculated potential difference A to B, B to D. Now what will be potential difference from D to A? We know very well that what is potential difference? It is product of current and resistance. So here if we see the current is I minus I1 and resistance is R, so potential difference will be equal to I minus I1 multiply by resistance R, that is I minus I1 dot R. So now sign, what will be the sign? Sign we have discussed earlier also that if the direction of the current and direction of our calculation is same, again repeating, if direction of current and direction of our calculation is same, then we will take potential difference as negative. And if the direction of calculation and direction of current are opposite, then we will take potential difference as positive. Now here if we see, we have calculated A to B, B to D. Now we want to calculate D to A. Now our direction is D to A, calculating direction is D to A, because we are calculating clockwise. So in clockwise we are going from A to B, B to D and D to A. Now our calculation is from D to A, but current flowing is from A to D, so it is opposite, so here we will take the potential difference as positive. So here we have written the potential difference as, see here, it is positive. Now we have calculated the potential difference across this closed loop. Closed loop, that is A to B, B to D, D to A. This is the closed loop, and we have calculated the potential difference. Now the sum of these potential difference, if we add these potential difference, then it will be equal to 0. So it is at the bottom, it is, and the next line goes into next line. So please note down, it is equal to 0. 0 is here and equal is here, so it should be here, but due to some when PPT making, it goes here, but it will be here. So you just understand that after equal it is this 0. Okay, now see, now we have added minus I1 dot P minus Ig dot P plus I minus I1 dot R equal to 0. This is the second law of Kirchhoff, and also we have applied this rule on our loop ABDA. So similarly we can calculate the same procedure for the for calculating potential difference or applying the Kirchhoff's loop law on the loop BCDA. BCDB. This is the BCDB. Okay, this is the loop, and we can apply the same Kirchhoff's law on this loop also, and we can calculate easily that here if we want to calculate the potential difference between B to C, our direction of calculation is clockwise, and the direction of calculation is from B to D, because we are calculating clockwise. Clockwise means B to C, C to D, D to B. So according to our calculation, we are going from B to C. So direction of current is also B to C. So the potential difference will be negative, and also here B to C, the current is I1 minus Ig and resistance is Q. So potential difference will be product of these two, minus I1 minus Ig dot Q. That is उसके बाद then we can calculate from C to D. C to D, it is I minus I1 plus Ig. So this is the current, and S is the resistance, so you can calculate easily. Now here it is B to D to B, you can calculate easily by multiplying current and the resistance, because the calculation is from D to B and the direction of current is from B to D. Okay, so it is positive, so we will take potential difference as positive. Okay, when it is opposite, then it is positive. When it is in same direction, then it is negative. One thing is more, that some of the books write for same direction of calculation and current, they take potential difference as positive. So don't be confused. In that you can also take in that way also, that if the direction of current and that direction of calculation are same, then you can take potential difference as positive, and if they are opposite, then you can take the potential difference as negative. But here I have taken in same direction. If they are same direction, then I have taken negative, and if they are in opposite direction, then I have taken positive. You can also take it in the reverse way. Now now see here, we have calculated the two loops. If we see here, when the Wheatstone bridge will be balanced. We have discussed also earlier that if there is no current flowing from B to D, then this Wheatstone bridge is balanced. So if we take Ig is equal to 0, the bridge is said to be balanced. So if we put Ig is equal to 0 in these both the equations and solve these equations, okay, try this in your notebook. Put the value of Ig equal to 0, and if you solve these equations, what will you get? You will get this equation. Again repeating, put the value of Ig equal to 0 in both the equations and then solve these equations, and then you will get P upon Q equal to R upon S. And this is the fundamental equation for the Wheatstone bridge. Here if the Ig is equal to 0, that is Wheatstone bridge is balanced, then we can put the P upon Q equal to R upon S. Always remember this formula. So this is the Wheatstone bridge.